Direct and inverse variation. How do you know that that's what we're talking about today? Oh, it's the title of the worksheet and it's on the sideboard. You already copied those down on your lesson plans, right? Good. Okay. So for each one of these situations described, let's write an equation that relates the two quantities. And then we're going to complete the table. A square with a side length x unit has a perimeter of y units. How do we find perimeter of a square? Add all the sides, right? What's special about the length of the sides of a square? They're all the same. So if we're trying to find an equation to find the perimeter of this square, the perimeter is what? X times 4? Is that what you said? Can we write it instead like this? Why do we write it like 4x instead of x4? Yes, that's the right answer. Because. That's why we do. Okay? It's a traditional way of writing. The numbers come first, then the variables. No big deal. Okay? So if x is 3, if the length of the side is 3, what is the perimeter? What is y? What is 4 times 3? 12. If the length of a side of a square is 7.5, what is its perimeter? If x is 7.5, what is y? 30. Good. If the length of a side of the square is 7.5, what's its perimeter? If x is 9.5, what is y? Okay. Any questions so far? Everybody understand where this equation come from? Okay, what about this one? How is this one different? Right, we're not talking about perimeter anymore. We're talking about area. Good. Okay, so a rectangle with the length of x units and the width of y units has an area of 60 units squared. What kind of equation can we use to find x and y? Yeah, how do you find area? Well, at the very basis, we have x times y equals 60, right? But if we're at the end, if we're trying to solve for y, wouldn't that be y equals 60 divided by x? Like you said, right? Okay. So if x is 4, if the length is 4, what's the width? What's 60 divided by 4? 15. What about if the length is 8? 7.5. What if the length is 12? 60 divided by 12? 5. Okay so far? Let's talk about a man and a tree. A man 5 foot tall casts a 3 foot shadow. At the same time of day, a tree y feet high casts an x foot shadow. What kind of equation are we going to set up here? Like a proportion? Is that what you're saying? Okay. So what would our proportion look like? Tall over shadow. So tall over shadow equals tall over shadow, right? So 5 over 3. What if I was just trying to solve for x, though? Excuse me. Just trying to solve for y. I can multiply x on both sides like we talked about last unit, right? And get y equals 5/3 x. Okay so far? So what if x is 4.5? So I'm saying, what if the shadow is 4.5? How tall is the tree? Isn't that what I'm asking? Okay, so if x is 4.5, 4.5 times 5/3 is? 7.5. Good. What about if x is 9? Are you sure? Yes. 15. Now, if you're sure, I want you to be sure. But if I ask you if you're sure, look back. Okay, you got it though? Good. So what about if x is 10.5? 17.5. Are you sure? Good. So I know you guys do this all the time. You stand away from a wall with a mirror on the floor in between you and the wall. And you look in the mirror and see how high up the wall you can see. Don't you? Every day, okay? Twice on Tuesday. Excellent. That's good to know. Okay. So this person is 60 inches tall. So isn't that similar to this problem we just did? It's just a proportion again. Okay? So we can do the height up the wall equals the distance to the mirror. Or excuse me, the height up the wall over the distance to the mirror. So this would be the height up the person over the distance to the mirror. Right? So how do I solve for y? If I just want to solve for y, this time I'd have to multiply both sides by 30, wouldn't I? And get y equals 1800 over x. So what if the distance from the person to the mirror is 20? How far up the wall can you see? 90? Because 1800 divided by 20 is 90. What about if x is 40? 45. What about if x is 60? What's 1800 divided by 60? Everyone's doing this in your calculator, right? You're just not just waiting for me to write it or someone else to say it, right? So glad to know that. For X people to travel, the cost for renting a bus is $7.50 per person. For the record, that's totally not even close, just so you know. If you've ever had to rent a chartered bus for anything, it'd have to be a really long chartered bus for it to be $7.50 a person, just so you know. Okay? So what kind of equation would we look for here? Are we looking for? The cost is going to be what? 7.5 times x, $7.50 per person, right? Okay. So what if we're having 10 people? What if x is 10? 75. You did that without your calculator? That's so amazing. Oh, I don't know. I don't know why. What about if x is 25? What if we're taking 25 people? And what if we're taking 30 people? Okay. So what if it's presented a little differently? The bus will cost $180 to rent. If X people ride, how much will it cost per person? So we know that it costs $180 for X people at a price per person, right? So how could I do this if I was just trying to solve for y? So y equals 180 over x. Good. Any questions about where that came from? If you know where it came from, raise your hand. Okay. So if you don't have your hand raised, you don't know where it came from? Is that correct? Okay, so we have 180. You can put your hands down, thank you. 180 is how much it'll cost. And we know if there's X people coming, they're going to pay Y per person. So if we have X people coming at Y dollars per person, it'll cost a total of $180. Is that better? Okay. So what if X is 8? What's 180 divided by 8? So that means they're paying $22.50 a person. All 8 people, right? What if there's 12 people? 15? What if there's 30 people? What does that mean? 30 people are paying $6 each, right? Does that make sense? So let's do some comparing. Look at problems 1, 3, and 5. Those are the ones on this side. Problems 1, 3, and 5. What do they have in common? Look first at their tables. If X does something, then Y does something. Look at their tables. If X increases, then Y what? Very good. Does anybody agree with him? Besides me? Okay. What's happening in problems 2, 4, and 6 on the table? The x's are, yes, there. If x increases, what's happening to the y's? Are they? Are all of them decreasing? Yes. So look at the relationship between x and y. Okay? Look at the relationship between x and y. They have a constant a constant ratio. Another word for that, what if this was a equation? What would we call this 4 right here? Yes, we would call it a coefficient, but specifically to a linear function? What would we call that 4? What would we call this 5/3? How about a slope? When we call it a slope? Or a rate. Okay? On the other hand, 2, 4, and 6, these over here have a constant what? How are x and y related? X and y have a constant product. So what about their equations? Look at 1, 3, and 5 on the left-hand column. What about their equations? What do they all look like? Yep, they all start with y equals. Then what? So y equals something times x, right? We're going to call that something k. No, it does not stand for Kingston, although that would be nice. What's funny is it actually stands for constant, but hopefully we all know that constant actually starts with a C. No, really, constant does start with a C. I'm really sure. Okay? So what about 2, 4, and 6? What do those equations look like? So what do they look like? Y equals k over x. Is there some other way that they can look? Like, look at that one. Look at that one. Could they also look like yx equals k? Wait, aren't those really the same thing? It actually might depend on what you're trying to solve for, right? Whether you're trying to solve for y or whether you're trying to solve for k. Correct? So tell me the term. What's this one called? That one's called direct variation. Okay? What's the other one called? Inverse variation. You knew that right off the top of your head? How'd you know it was called that? Oh, the title? Yeah? Direct and inverse variations? How else did you know we were talking about direct and inverse variation today? Uh-huh. It's on the board, right? It's on the sideboard on your lesson plans. Okay? So, here's a sample. If we're talking about direct variation, here's the sample problem. If y varies, directly as x, and y equals 12 and x equals 8, then what is y when x is 24? So here's how I want you to do a problem like this. Can I show you the easy way and not have to worry about the other ways? That would be great. Okay, here we go. So we're going to start reading. If y varies directly as x, okay, that tells me a huge deal. It tells me I'm going to be using that equation, y equals kx. And y is 12 and x is 8, and then I'm going to stop reading. Because I know that y is 12 and x is 8. If I know y and I know x, what don't I know? I don't know k. And I need to know k. So I'm going to start with this equation, y equals kx, and I'm going to put in what I know. Y is 12, x is 8. Y is 12, x is 8. Is this going to help me find k? Yes. How can I find k? Divide both sides by? K equals 1.5. And then I'm going to start over. I'm going to rewrite my problem, except this time I know what k is. Whoops, that should say x. So I start reading and read until it gives me some information, and then I stop. I go find k, and then I start again. What is y when x is 24? Well, how do I find that? Can't I just plug in 24 for x? It tells me 24 is x. What is 1.5 times 24? So, if y varies directly as x and y is 12 and x is 8, then y is 36 when x is 24. That is my solution. Okay? So what's it going to read over here? If y varies inversely as x, and y equals 12 and x equals 8, should I stop right there? Yes. Because what do I need to find? K. Which one of these two will help me find k easier? You already told me they were the same, right? You already told me they were equivalent equations. So which one is going to help me find k easier? How about the one that's set equal to k? Right? So xy equals k. Y is 12. X is 8. What's 8 times 12? K is 96. What should I do now? Start over. Okay? But see, this time it's asking for me what y is. Which of these two equations, even though they mean the same thing, which one is easier if I'm trying to solve for y? Probably this one, right? Y equals, except it's not k over x, because I already know that k is 96. So what is y when x is 24? Yeah, you're right. It's just as simple as now putting 24 in for x and doing the division. So if y varies inversely as x and y is 12 when x is 8, then y is 4 when x is 24. Okay? Any questions about any of that? Last page. This is your homework for tonight. Look at the first 4 questions. Identify whether each table shows direct variation, inverse variation, or neither. I hate when they throw that neither in there. I just want to be able to choose one or the other, right? Well, if they add that neither in there, I have to know why I'm choosing one or the other, right? If I'm trying to choose between a table, what's going to tell me if something's direct or inverse? If the x increases and the y increases, then I know it's going to be direct. If the x increases and the y decreases, does that automatically make it inverse? Does increasing and increasing automatically make it direct? It doesn't, right? This is telling me a general form. Then if they're both increasing, they have to have a common ratio. If I divide the two numbers, it has to be the same thing, right? If this is increasing and y is decreasing, x and y have to have a common product. I can multiply x and y together and get the same number. Look at 2. X is increasing and y is decreasing. So that would mean inverse, but for it to be inverse, I have to have a constant product. X and y, x times y is 44. X times y is 50. X times y is 56. Is that a constant product? What is this? You get the idea. These 6 questions right down here at the bottom are very similar to the ones I did for you down here on the bottom of this page of these notes. All right? So look back here if you need any help, or ask a partner or ask me. Are we good? Any questions about this?